Welcome! Ever notice how continents look like puzzle pieces? That's because they once were connected. Earth's surface is split into massive tectonic plates always on the move. These plates drift because of convection currents in the mantle. Hot rock rises, cools, and sinks, dragging plates along. It's a slow process, just centimeters per year. But over millions of years it reshapes our world. Where plates meet, we get dramatic events. Mountain building, earthquakes, and more. Today we'll explore the three main types of plate boundaries: divergent, convergent, and transform. Let's dive into the science of our ever-changing planet. First, divergent boundaries where plates move apart. Picture the Earth's crust stretching like taffy, creating a rift. Magma rises to fill the gap, forming new crust. Most of this happens underwater at mid-ocean ridges, like the Mid-Atlantic Ridge, which is making the Atlantic Ocean wider every year. On land, divergent boundaries create rift valleys like the East African Rift, splitting continents and forming volcanoes and lakes. Earthquakes here are usually shallow and less intense, but the main story is creation new land forming from below. Divergent boundaries are the planet's way of renewing itself. They build new ocean floors and slowly reshape continents. It's a constant constructive process. Now, convergent boundaries, where plates crash together. When oceanic and continental plates meet, the denser oceanic plate dives beneath in a process called subduction, melting and fueling coastal volcanoes like the Andes. When two oceanic plates collide, one subducts, creating volcanic island arcs and deep trenches, like the Mariana Trench. When two continental plates collide, neither subducts. Instead, the crust crumples upward, forming massive mountain ranges like the Himalayas. These collisions cause powerful earthquakes and, in some cases, ongoing mountain growth. Convergent boundaries recycle crust, build mountains, and trigger some of Earth's most dramatic events. They're the planet's recycling and mountain building centers. The forces here shape the tallest peaks and deepest trenches on Earth. Finally, transform boundaries where plates slide past each other. There's no creation or destruction of crust, just grinding motion along faults like the San Andreas Fault in California. The plates can lock together for years, building up stress until it's released in sudden, often destructive earthquakes. The landscape shows evidence: offset rivers, bent roads, and shifted fences. Transform boundaries don't build mountains or volcanoes, but they're responsible for frequent shallow earthquakes. They're found worldwide, including the Alpine Fault in New Zealand and along mid-ocean ridges. These boundaries remind us the ground beneath us is always moving. Their impact is felt by millions living near active faults. From seafloor spreading to mountain building and earthquakes, plate boundaries shape our world. Understanding them helps us prepare for hazards and appreciate Earth's ever-changing nature. The evidence is everywhere, in rocks, mountains, and the shape of continents. Our planet is dynamic, beautiful, and sometimes violent, all thanks to moving plates. Next time you see a mountain or hear about an earthquake, think of the boundaries at work. Keep exploring, keep asking questions. Science is all around you.